Good morning, everybody. We'll get started with the session. I'll first introduce myself and then I'll quickly introduce what I'm talking about. So my name is Mohannad Hussain. By day, I work for FHIR. I like to think of myself as a software engineer. I'm doing less and less of that, unfortunately. I also volunteer with some organizations like SIM, working on the annual hackathon and other things too, as well as other projects of interest in the general healthcare world. Today, in this community presentation, I'm actually going to give you a two-in-one presentation. So I'll talk about two different projects that I've been involved in that are both of interest to the imaging informatics community. So the first one is the SIM hackathon dataset. We'll dissect every one of these words in just one moment. So first, what is this SIM thing? Well, SIM stands for Society for Imaging Informatics in Medicine. It's a US-based organization that is advocating for imaging informatics. Okay? SIM is an annual educational conference, and I emphasize on education because a lot of you may have heard of things like RSNA and other organizations. These are usually more about, the show off, the flashy stuff, the sales. SIM is different. SIM is all about education. You show up for SIM to learn about things and exchange knowledge with people. So sort of like the setting here. If you're interested, the next one is taking place in Washington, D.C., May 31st to June 2nd. So consider this to be your invitation. We'd love to see you there. Now, the SIM hackathon came about in 2014. SIM became very interested in becoming an evangelist for FHIR and DICOM. SIM saw the value in improving innovation in healthcare using these two new standards, among others, but these are the main two. So SIM held its first hackathon in 2014, and then very quickly realized that you needed a good data set to be able to work with these APIs, to be able to test and develop things against them. So, to accelerate the pace of innovation, and instead of giving people random data set to test with, SIM decided, why don't we go and create something that looks realistic? Okay? And in a moment I'll tell you the other cool thing, other than the fact that it's realistic. So what is it is a set of 5 patients. This is as it stands right now. We're constantly looking to expand the set. So we may add more patients in the future and as well as more resources. But yeah, right now it's 5 patients with data sources in both FHIR and DICOM Web. And this is one of the big advantages here. This is not something you come across very often. If you're looking for a sample FHIR data set, you'll find plenty. If you're looking for a sample DICOM set, you'll find plenty, but you won't find many data sets that have both. This is one of the points where the SIM data set is very unique. And each one of these tells a story of a fictional patient, but it tells a very realistic story. So the information lines up. It's not random. There's no conflicting information in that data. And of course, the other big selling point about this data set is that it was heavily developed by real-life radiologists who help make up these stories. So again, we're the best of both worlds. It's anonymized data. You're not working with real patients. You don't have to worry about privacy concerns. But at the same time, it's very realistic looking, so you can actually build an app around it. And if I go back to my other slide here, this is actually this picture. It shows an app that was developed at the hackathon, where because it was realistically real-life data, it actually looked pretty nice. It's not very obvious in the screenshot, but it's a timeline view of a patient. So it shows all the different labs they did and imaging exams and stuff like that. So you can only do that with real-life data that actually lines up. It shows you history. This data set is MIT licensed, so it's open source. Not only you can use it as much as you like, but of course we encourage you to contribute to it if you've got interest and you've got time. You're more than welcome to use it on your own servers. If you've got a FHIR and or DICOM web server, you can use it with that. Or if you wanted, SIM actually hosts servers in the clouds, both for FHIR and for DICOM web. So you can use SIM server, which basically gives you no barrier to entry in that sense. It's completely free to use it. The only catch is you have to have an API key that's given by SIM. The key doesn't cost anything, but they just like to know who's using the API, just mostly for analytics more than anything else. For those of you who are interested in checking it out, here are the links here. So you see the top link is the FHIR dataset, and then the second one is the actual .com images. If you like to write it down, take a picture. I'll keep the slide up for a moment, but I was going to say, you can always Google it, and I'm sure you'll find it very quickly. And if you don't, feel free to get in touch with me, and I'll be more than happy to send you links and connect you with people if you have questions or things. Here's an overview of what the data set looks like right now. So you see at the top, you've got the 5 patients, and then in green, you've got the imaging studies that they have. So this is the variety right now. And then in orange, some of the FHIR resources that are available right now. And again, all of this is a cohesive data set. Everything connects, everything lines up properly. Some credits. These are some of the people who have participated in this data set. And you'll notice I highlighted the gentleman in the middle, Dr. Mark Coley in orange, because he is really the catalyst behind all of this data set. He's done so much work into the data set, it's quite amazing. But yes, about roughly half of these are actually radiologists. Okay. Next, we'll talk about DICOM proxy. If there are any questions, I'll answer them at the end. So the DICOM proxy is a different project altogether. In fact, it's sort of like 2 projects that run in parallel. So the problem is, DICOM Web is amazing. Everybody likes the idea, but where is it? Nobody seems to have it yet, or at least nobody seems to have a mature enough implementation. So it really sucks. It would be nice if you could just have it today, wouldn't it? So what can we actually do to make this work? So here's the use case that we're trying to solve. Imagine if we could put a proxy or some kind of facade in front of your traditional PACS or VNA to make it speak DICOM Web. So it's almost like a translation service. You take in, you have an app, which is the iPhone there. It can speak DICOM Web to this proxy service that you put in the middle, and then that proxy service translates that into traditional DICOM DIMC, and then everything just works. It would be really nice. And of course, you can install this in front of your PACS and run your organization, and voila, you can essentially retrofit your old PACS VNA to the modern age, basically. These 2 guys worked on the first prototype. So this was done about 6 months ago at the SIM Hackathon. A proof of concept was developed, where basically that proxy was developed to take in DICOM Web and translate it to DICOM DIMC. So these 2 guys actually did a proof of concept. However, in parallel, it turns out somebody else also had the idea. Luckily, they actually had more resources to build it. So RSNA and an organization called Sync for Science, both US-based, actually teamed up to build that DICOM RESTful server. Now, instead of calling it DICOM Web Proxy, they actually called it RS Broker, which stands for RESTful Services Broker. We'll talk more about it. They were interested in it because they wanted to make studies, accessing studies for research easier across something that's already in place, which is the RSNA image sharing network. So, in Europe, you probably have a lot of XDS sharing infrastructure. This is sort of the North American equivalent. It's quite different in structure, but it's close enough. So these guys, Sync for Science, built this proxy. This is actually available now. You can go try it out, completely open source. As it stands right now, you can put this proxy or broker in front of your PACS or VNA, and it will let you do query, translating key to ORS to cfind, and retrieve, translating Y to ORS to cmove. Both SIM and Sync for Science would like to extend support for other things. We don't necessarily have any specific timelines, but it would be nice in the future to add support for more. So being able to store your images, so STORS to CSTOR translations, as well as things like modality work lists, so the tasks API, translating from UPS-RS to modality work list service, and in the future maybe even more and more things. That would be really valuable. It would solve a lot of problems that we have with current implementations. So just to quickly reiterate what's in it for these guys, just to make it a little bit more obvious. What they envisioned is an easy way for patients to decide that they want to enroll in research. So they want to volunteer their information, their records, their images for research studies. And basically the way they envisioned it is that the patient shouldn't have to do anything else but just click a button that says, yes, I volunteer, and the rest automatically happens. This is what they did. So by making this implementation, all the patient needs to do is say yes, and then they can use all these RESTful APIs to pull, whether from FHIR or .com Web, and the whole thing just works really beautifully. Okay? The idea is they would install this proxy service at the different institutions, and then they could pull over the internet. If any of you is interested, here are some links. So the very first link is describing essentially the architecture and the vision they have behind this project. The second link is where you can actually find the code. You can compile it and you can run it if you want it. But of course, if you just want to run it, you probably want the Docker, because that's the low cost of entry there. I highly encourage reading the vision document. It's actually very concise, and it's got easy to follow instructions and ideas and whatnot. And it will also give you a glimpse of how it works as well, which is very, very interesting from a technical point of view. And it just keeps getting better. So we talked about how they built a DICOM RS broker. They also built a FHIR broker. Now this one is a little different. What this one does, it's essentially a FHIR server, but it's very limited in nature. It's FHIR server that actually emulates FHIR resources based on DICOM information. So you come to it asking for, let's say, studies for patient A. Instead of actually getting them from HL7 information, it will go to the DICOM PACS or VNA, compile that list, and return it to you. That's why it's emulating things. But again, if you're interested in this, feel free to follow the link. This is the same link I've shown in the previous slide, and it will actually explain a bit more about how it works and exactly what it is. Again, all of this is open source. You're more than welcome to use it, extend it, contribute, whatever you like. That's it for me. Questions? Concerns? We've got 5 minutes, so lots of room. Yeah.
Web proxy, is it available freely, or the first one you showed?
So the first one with a picture of the two guys, that's just pure proof of concept.
Okay.
As I said, the title of this slide was saying great minds think alike. It's just that, two different people from different backgrounds, or two different groups, I should say, thought about the same thing. So that's just more the history. But yeah, what these guys built, unfortunately, didn't go too far. But then, in parallel, Sync for Science and our name as proxy, which is, in my opinion, a lot more useful.
Is it feature complete, the second one?
Depends on how you define feature complete.
Can you retrieve study information and then the standard compressions like GPG, window level?
I honestly haven't had a chance to take a deep look at what exactly they support. I know it's functional and definitely supports some kind of bare minimum level of things, but how far do they go? I'm not 100% sure, to be honest with you. If I had to guess off the top of my head, and this is completely uneducated guess, I would say they probably don't implement rendering. They probably implement just retrieval of DICOM objects, but they're not actually doing JPEG render yet.
And it's, as I understood, it's being used in production in the United States too.
Yes, it's used in production, but at a very limited scale so far. They're hoping to expand the scale more and more. This is all brand new stuff. I mean, this materialized in the last couple of months. So as you can see, this is very, very new. It still has yet to gain more traction and enjoy more use.
Okay, thank you.
Yeah, no problem. Any other questions? We've got 2 more minutes. good day.
Okay, good morning, and I want to thank you all for allowing me to talk through our platform and how FHIR has ultimately helped to accelerate and propel us forward. I'm Ivan Sager, and I lead our social cares services and business solutions division. The accent you're hearing is originally many years ago from South Africa, but I'm very glad to call Austin, Texas my home. So I must say I've been very humbled by coming to this conference, because when I arrived at the conference I thought I actually knew quite a bit about FHIR. I've been working FHIR and so on and so forth, but clearly it's very, very broad, and the community here is extremely deep and very broad and very understanding and very willing to share details and experiences on FHIR. So truly it's been a very humbling experience, but what I will say is it's also been very rewarding for me. And the reason for that is back in 2014 we decided to scale out our platform. So we had to bring vast amounts of clinical data and other type of data together into one central area. And the EDW, the Enterprise Data Warehouse approach, wasn't working for us. It wasn't working for two main constraints. Number one, the cost of acquiring additional data feeds into that environment. And those new data feeds could be from legislation, or it could have even been from clinical care protocol changes. That change and that cost and cumbersomeness of having to map all of our rules into one structure was really not working for us. But I think the bigger thing that was difficult for us was the constraints on a very rigid data model in sort of that EDW world, where our lead architects would have to figure out these data structures or the relationships up front at the very beginning and be perfect on those. And I think clearly we know, that's an order, a chance. Clearly you know that that's I'm talking too much. Clearly that's a big problem. So what we did is we went with FHIR 180. Let me grab what my water now. Give me a second. Happens when you talk the whole day. So what we did is we went with FHIR 180, And we knew FHIR would change and the standards would grow, but we implemented on 180. And the reason we did that is the FHIR community, thank you so much, the FHIR community, their thinking around how they map data and how they persist resources was exactly aligned with the way we wanted to do it. So we implemented 180, and fast forward today, FHIR has really been the right choice for us, and it's really helped us move forward. So beyond FHIR, we always had interoperability at the core of what we've done. So we are Meaningful Use 2, Meaningful Use 3 certified, so we've always focused on bringing data together in a standard way and supporting interoperability. So what I was thinking of doing is talking through a couple of use cases and problems that we've solved in the US healthcare market. And then the next slides, I'll talk through some of the ways that we've solved them and sort of always open for feedback to understand how others have done it. But here's what we typically are solving in the US space. We believe much innovation in the healthcare space will come from individual application developers and development of these smaller applications to support healthcare. The EMR vendors certainly will innovate in their space, but we believe the rate of innovation and the acceleration of innovation in the healthcare space will come from folks like us, individual developers, organizations creating those applications. The problem that we are finding is that the barrier to entry to create these applications in the US healthcare space is very, very difficult. So if you even start at the very bottom, just the acquisition of data. Some folks have FHIR, some have legacy systems. Acquiring that data and getting that data is a big barrier for many organizations trying to develop applications. So we're trying to chisel away at that. Let's figure out the acquisition. Let's start getting acquisition into our platform so we can allow other engineers and other organizations to take advantage of that. And as you start walking up that stack, things like legislation and even security, there's a notion in the US called high trust. I think in Europe there's something called GDPR, a very similar concept, which is a very high trust environment. So if you think about in the US, some of the insurance companies, large insurance companies, United Health Group, if we as an organization, developers, software vendors want to build applications and even play in that space with their environments or any of their continuum of care organizations, you have to be high trust certified. You cannot play in that space unless you're high trust certified. And for you folks that know high trust or know the security requirements, it's costly, very expensive. And as a result, what you're finding is these developers who want to bring innovation and want to bring sort of goodness to the healthcare space, they can't do that because the barrier of entry to getting to that just from the acquisition, just from the high trust security is too high. So what we do is we are a high trust certified platform, we've got data acquisition engines. We really encapsulate those initial barriers to entry. And what we try and do is, if you look at the purple area, our platform covers those areas. So we bring in the data acquisition, we bring in the high trust, we bring in the aggregated data and the standardized data through our FHIR platform. And then what we do is on this top part here, we allow our developers to really focus where they want to focus the time, and that's their unique IP on the applications that they are building for their organizations. So what we're doing is we built the platform, we've got a couple of pieces that are really helping accelerate development. We will continue to monitor and measure and manage that. And as we find more commonness from the application developer community, we'll start building that into our platform until we get to a point where application developers can really focus and keep their applications very light, but what they focus on and what they build is very specific for their domain, and they're not having to sort of be run through the ringer around sort of the mundane and the commoditized stuff. But without that, you cannot get into the application space. So that's sort of one big area that we focus on, is really helping the application developers. The next one is the EMR space. So often what happens is the CIOs or CMOs of the business organizations come to us and say, hey, we have standardized on a single EMR platform. but we're not seeing any other return on investments. Things are not working out the way that we thought they would. We standardized, we have one EMR, but it's not working for us. Well, of course it's not working for us, because we all know the reason, right? A single EMR is really, platform is only a single EMR platform until the very first time that you acquire another clinic, or you go through merger and acquisition, or even more so when you take on risk-based contracting, which in the US is sort of seen as accountable care organizations or value-based care. So typically what happens is, if you take on a risk-based contract, you as a hospital don't own all the cardiologists or don't own all the nephrologists in your hospital system. Those folks are spread around the communities. So what you have to do in risk-based contracting, you have to figure a way to work across all these different clinics and all these different physicians. And guess what? They don't all have the same EMR. They don't, some of them, especially in the rural areas, they have very old EMRs. In fact, some of them have spreadsheets that they use. So that notion of a single EMR or a single platform, while aspiration, that's where we do want to go, maybe as a hospital system, it's not the reality. So here's what we do in the most simplest form on our platform. You know, I guess I'm old school, I call it crosswalk. I think the new term, or in this conference is talking, it's terminology services. It's the same thing, whether it's crosswalk or terminology services, I refer to it the same. But we have this connected technology, which I'll talk through on the next slide, but ultimately in the most simplest case, here's how we're helping solve these CRO dilemmas and really bringing return on the investment on the platforms. Number one is we are able to connect to these EMRs, these sort of smaller EMRs, whether it's even just through database connectivity, APIs, for FHIR and so on and so forth. And we are able to crosswalk between the hospital system, who may be on ICD-10 because they have the resources to run there, versus the smaller clinics that are still on ICD-9, or they're using SNOMED and Long. So arguably this is table stakes now. When we built it, it wasn't, but we are able to do this traversing between these different systems, and we believe by doing that, interoperability is really at the platform level. So what we're able to do is take codes from one system, bring them in to the other system, or provide the crosswalk for the other system. But again, that's table stakes. What I think is more exciting and fun, in all transparency, what I'm talking about next hasn't been pushed to our production branch yet. This is all in our dev and in our QA branch. Here's another thing that we run into when you talk about these different clinics and these different systems. Especially in some pockets in the US, for example, Texas, there's a lot of areas that have pockets of very focused demographic areas. So for example, in Texas, you may have clinics that are serving a very specific language barrier. So for example, you may have clinics where 100% or most of the population are Spanish speaking, for example. So what we're doing with the platform is we are starting to take the physician notes that they've entered into these EMRs, because we believe the notes are truly the most subjective data we have today in healthcare. So what we're doing is we're taking these physician notes, we are running them through our NLP. We're also tinkering a little bit with machine learning, but suffice it to say, what we're doing is we're pulling down the data, the physician notes. So for example, a physician, this is actually Afrikaans, my second language, Hussain met pain op die bors. I think for Dutch-speaking people, you should understand a little bit of that, because Afrikaans can subset Dutch. So what we do is we run it through our platform, and at the end of the platform, we get a translation saying patient presents with chest pain. These are some of the ICD-10 codes and the SNOMED codes, and here are some additional insights that may translate to what patient presents with pain in the chest means, AMI and so on and so forth. But here's the key thing, what we are not doing, we are not taking data and shoving it into the other EMRs and so on and so forth. What we are doing is we're taking this vast amounts of data from these EMRs, we're running them through some machine learning and natural language processing and presenting that limited data to the physicians to make that choice. So we're not shoving it back into the EMR. And the reason we're not doing that is, at the end of the day, the physician working on that one platform, or even sort of these connected platforms, they are still responsible for the care of the patient. So we cannot take some information and all of a sudden assign it to a physician, a patient chart, and say, well, now we're telling you that the patient has an AMI or the patient is diabetic. But what we are doing is taking this vast amounts of data and we're distilling it down to something that a physician then can ultimately still make the final determination. So that's one key thing that we find is we don't believe that just shoving data back and forth into an EMR is always the right answer, especially when you're doing these translations. The physician is still accountable. The physician knows what is best for our patient. But today, physicians are struggling because they have a slew of information. There's no way to distill what's sort of signal and what's noise. So that's one of the big things that we are doing, and I think that's honestly where a lot of the market's going to go. I think the NLP and the machine learning, there's going to be so much data, so many rules. I don't think people are manually going to be able to continue to keep up with the rules and the translations. You're going to have to start having some level of insight to distill information, distill noise from signal. So that's one area, another area that we are focusing on. So I guess the next question is, well, how are we doing this? So there's a couple of pieces to that. When you think about typically our social care deployment model, there's sort of three parts of the equation, if you will, in the most simplest form. On the one side, you typically have your EMRs and so on that medical practitioners are using. In the center, you have sort of the social care high trust platform, and on the far side, you have all these applications, whether it's hosted applications, SaaS applications we've written, and so on and so forth. So here, I'll jump into the next two slides, which will talk through this acquisition component, and then talk about a little bit of our mapping technology. So starting off with our acquisition, I mentioned earlier on the data acquisition process is very difficult. This connector architecture was built before FHIR had really caught on fire and so on and so forth. So what we did is we have a pluggable connector architecture, which ultimately obviously has HL7v2, because that's sort of been the big player at the moment. But it also has some SFTP connectors. So basically what this does is it allows us to integrate bidirectionally with these EMRs. We have, it's actually I think 40 or 50 plus EMRs, but it's a significant number of EMRs, because even the different versions within the EMR we have to account for. So we have this pluggable architecture that enables organizations to install these agents within their environment or within our high trust environment and extract data from these EMRs. We are working on a FHIR adapter right now. It's tricky. It's interesting. Another way of saying it's very complicated to figure out some of those things, especially when you have a moving standard. But we continue to push forward. But another very cool thing about this connector architecture, the way that we're pulling data out of the EMRs, whether it's FHIR-based or even some of these older database-driven EMRs, is that we also have a self-service configuration. The reason we do that is because a lot of these organizations are smaller organizations. They don't have these big IT teams. So what we do is we allow them to download a very small pluggable. They download that. They have a code when they download that. And they can configure that themselves. And once they configure that, the data is extracted, and we normalize that into our platform through FHIR. So that's sort of the acquisition component. And the other side, the middle part of the equation, which is somewhat our secret sauce, if you will, is that what's interesting is some of the organizations, when they have an EMR or they have an application, they call our platform and they ask for FHIR in version 2 standard. Even a similar clinic under the same organization, they have a different platform, they have a different set of applications, or go under the same clinic, and they have V3. So what they are doing is they're calling our platform and saying, for that same patient, we want the data back, but we want it back in version 3 format. So that whole translation, that mapping, if you will, is what we're doing in our mapping technology. Now, we have really two pieces. We have a graphing technology we built. If you think about FHIR, it's sort of a very hierarchical, sort of traversing infrastructure. A lot of the reporting type tools, and whether it's MicroStrategy, Tableau, they really need more of a flattened out structure. So that's what we do in terms of our graphing technology. We also have a document repository. Under the hood, we are a Java-based Mongo sharded environment. So what we are doing ultimately with this mapping technology is we are hydrating different Java objects, and we are copying those Java objects back and forth through our mappings to allow people to call FHIR one way, get back FHIR 3, or even other versions in the other way. Now, look, we're dealing with hundreds of requests today, and I wouldn't say there's no overhead in doing that, but we haven't found that the overhead has been a problem for us. I'm sure that once we hit 10 million or so transactions, we will have to tweak things, but our model has never been, let's try and build for the world. We say, let's think sort of very globally, but let's really execute locally and make sure we can make progress forward. So that's sort of the way that we are able to bring in different data, persist that data, and allow different organizations and different clinics to get these different formats in. So again, what I would say in summary here is at Social Care, we're not trying to boil the ocean. We understand that there's a lot of unknowns, but what we're doing is we're taking the slivers of the market where we see the biggest use cases and the biggest problems, and we're solving those in a way that we feel makes sense. And we found that FHIR has been the common denominator to bring the data together and allow us to run all these other algorithms and all these other sort of interoperability plays against all these different clinics. So that's all I had. What I would say is a big part of what we do at Social Care is we believe in fostering value together. So we build components, we build a platform, but we always look out for other vendors who are doing either something in a similar way that maybe is better, and we can plug into our architecture. We are a microservice architecture because we know things have to change all the time. So we want to have a way to move quickly and adapt. And also, as we find other organizations building things that we may not have, we want to partner with them because we do believe the value of the platform is the exponential technology. Taking one technology here, one technology there is really 1 + 1 is 2. But when you combine all these different technologies into a platform, that's really where you become the multiplier. So again, we always encourage to try and talk with others, learn from others, integrate other people's technologies into our platform. I want to thank you for your time. For those of you who are traveling, have a safe trip, and I really appreciate everything this sort of a community has done to help me learn some more on FHIR. And I do hope I get a chance to talk with you in the future. Take care. If there's any questions, come over or ask them.